Hello students, welcome to my class. In this video, we are going to focus on simple AC circuit. And AC is the current that varies sinusoidally in such a way to reverse its direction periodically. So in a circuit, AC current changes direction periodically, and we can represent the current or the voltage in an AC circuit as a sine function of time. For instance, the instantaneous voltage, the voltage at an instant of time in an AC circuit can be represented as V naught sine omega t, and the V is the instantaneous voltage. The V naught is the peak voltage, that is the maximum voltage in an AC circuit, and omega t is the phase angle. The phase angle is the angle between the current and the voltage in an AC circuit. So same thing, we can also represent the instantaneous current, the current at an instant of time in an AC circuit by using the function sine function of time of the changes in the current of an AC circuit. So that can be written as sine omega t. So, and in this case now, the I is also the instantaneous current. The I peak, I naught is the peak current, and omega t is the phase angle. So there are some things you have to pay attention to. So the first thing you have to pay attention to is the omega. So omega can also be equal to 2 pi f. So take note of that. So this course now, the first formula you know now is this one. So you have to know this formula no matter what. So, and also you have to also understand this function. So no matter what. So I will teach you how to use it to solve problems later on in this course. So another thing is that note that the omega can also be called angular frequency. This is the frequency, the frequency of the instrument. So the AC instrument. Then another thing you can also pay attention to is the phase angle. So phase angle is the product of the angular frequency and time, and is the angle between the current and the voltage in an AC circuit. So those are the things that are very important for now. So another thing you have to also pay attention to is schematic diagram or illustration of how voltage and current changes with time. Now let's see how voltage changes with time, how the graph will look like. So let's say this is the wave diagram. So I am sure you still remember all this now. So the if the y-axis represents the voltage and the x-axis represents the time. So this graph now, or this wave diagram, represents the changes in voltage with time. So the maximum displacement we have, The maximum vertical displacement we have is called the peak voltage. Remember we said peak voltage is the maximum voltage, the maximum. So the maximum voltage reached in an AC circuit. So this for um, the voltage. Now we can also do the same thing for current. So for current as well. So whereby this is the current and the time. So the maximum point reached is going to be the peak current. So the maximum current. So this is really very important. So the only thing you have to pay attention to here is just look at the y-axis and the y-axis or any of it. So then you pay attention to what is going to be here. So that's really very important. Now let's work on some examples on what I just explained. The first thing is that he said the instantaneous voltage of an AC power supply is given as V equals 10 sine 2 pi t. Calculate the value of the peak voltage, the angular frequency, and frequency of the instrument. So this is really a very simple question, but it can be very tricky if you don't understand the concept. So anytime you see a question like this, the first thing you have to think of is supplying the equation for the instantaneous voltage or current as the case may be. So this question now, what we need to know is what is the, let's say, solution. So the instantaneous voltage, which we know that is equal to V peak sine omega t. Then the first thing you need to know is to learn how to compare these two equations. Now, let's write the given equation down. V equals 100 sine 20 pi t. If you pay close attention, you can see that these two guys actually look very similar. The first thing is the V peak, the same thing as these two, so which is something as 100. So therefore, the V peak is going to be 100 volts. So we have solved the question A. Very simple and straightforward. Now, for the B part, so the B part, that is the angular frequency. So learn that the angular frequency is the omega, and we can compare these two guys. You can see that we can actually find our angular frequency. So we can say omega t equals 20 pi t, and t, we cancel t out, so we are left with omega equals 20 pi, and the unit of omega is rad per second, so therefore we have 20 rad per seconds. So very direct like that. Then the third question says the frequency of the instrument. Remember, I've already given you the formula about the omega, the angular frequency equals 2 pi f. Remember that. So now we know the angular frequency from the previous question. So that was 2 pi and 20 pi. Now let's supply that. So we have 20 pi equals 2 pi f. Then we can say pi cancel pi, 2 here 1, 2 here 10. So that's equivalent to 10 equals f. So we can say therefore the frequency of the instrument equals 10 Hz. So this is the solution to the problem.